Right, so welcome back to the second section talking about the T test. All right, so for the T test, um, we have been talking about, right? Our interest is to look at the independent T test. Okay, so we are looking at the independent T test. Independent T test. So independent in a sense that we believe that you have population A and then population B. All right, so these are two different populations. They have nothing in common. All right, so let's say these are blind people and these are deafs. All right, or these are, let's say, executives and these are just let's say security men. Okay, so security men and executives, we believe that these two populations are somehow independent. They kind of have different populations. So when I pick a sample from here and I pick a sample from here, I believe that these two samples I've picked are independent. Okay, so if I want to check the distributions, I will just be using the independent approach. All right, so this is what we are interested. All right, so in this section we are just looking at the independent T test. Okay, now when you decide to do an independent T test, all right, you have to decide also to do whether or to do either an equal variance or non-equal variance. Okay, so the first thing is that you decide that you are going to do a T test. Okay, what type of T test are you doing? Is it a dependent T test or independent T test? And we are saying we are doing independent T test. So now we are doing independent T test, we should decide whether we are doing equal variance or unequal variance. Okay, because when you choose equal variance, the formula changes. When you choose unequal variance, the formula changes. All right, so we are going through this direction. So we are doing a T test independent and then at the same time unequal what variance. So we are assuming that the two samples have different variance. Okay, so these are the assumptions. So the assumption is that we are treating our samples, we believe that they are independent, means they come from different populations, and then their variance, that is the variation around their mean, the central tendency, are different. So in that case we would also assume unequal variance. Okay, so this is the way we are going to. We looked at an example which would go through this direction to resolve the situation. Okay, all right, so now I remember I mentioned that to do a T test, you should be able to, the data point you have should be able to satisfy some assumption because it's a parametric test. Right, so for parametric tests like a T test, it has to satisfy some assumptions. So I think these are the assumptions that it has to satisfy. Let me see whether I can find that assumptions. So I mentioned earlier that when you have any hypothesis testing, you either do a parametric or a non-parametric. All right, and I said that to do a parametric test you should satisfy some assumptions. All right, so you satisfy some assumptions, at the same time you have to be quantitative. Okay, so quantitative and satisfy an assumption. To do a non-parametric test, it has to be categorical. All right, it has to be names, and then in this we don't assume a lot, so there are no lot of assumptions. So if the thing is quantitative and then you fail to satisfy these assumptions, then it has to come to, you have to come and perform a non-parametric test. Okay, so look, these are some of the assumptions for you to do a t-test. The data point has to be continuous. So for this specific t-test, it has to be continuous, strictly continuous. Okay, so we don't expect a discrete point. It should be continuous, which is quantitative, and then the data should follow normal probability distribution. All right, and then the variance of the two populations are equal. If not, we'll do unequal variance. So remember that I said t-test, you can either do equal variance or unequal variance. Okay, so any of this, either it's equal or not equal, we can still use the t-test to do that, right? And then the two samples are independent, so we believe that the two samples are independent, coming from different populations. All right, and then the both samples are simple random samples. So this another technique means we pick them using a random technique. We didn't just pick them anyhow, but there was a certain random technique that we used to pick each of the samples from their respective populations. Okay, so these are the assumptions your data point has to satisfy before you can consider doing a t-test. So whenever you are in a field working and then you come up with data sets and then you want to run a t-test, you have to just make sure that they in a way satisfy these assumptions, and then before you can carry on to do your t-test. Okay, all right, so that is basically what we are talking about. Okay, so let's take a typical example. Let's look at a typical example. So I have a Word document here, and then so a typical example is C. So this is a typical example. So example, the performances of trainee actors who have passed through a drama school are rated by a panel of experienced actors who assign an overall mark for each trainee. Okay, so the drama school has recently introduced a new training method which is claimed will lead to the better performance. So what this happened is that they believe that there is a certain training, or it's a drama school, so they believe that there has been a new training which would improve their performance compared to a certain existing training. Okay, so here there was already some training that was given to them, and then based on that training they perform for people to see them and then rate them, and then it's like kind of invention. You invented a new training, okay, and then you want to see whether these two trainings are somehow the same, but these people believe that the new one they brought is better than the old one. Okay, so this is just somebody's claim. So the underlying word here is they claimed. All right, so it is claimed. So when you say claimed, means it's just an assertion, it hasn't been proven, so it is up to us to go and prove. So he says that the marks for a random sample of 6 trainees using the old training method were that. So they came in that, okay, let's use the old training method and then give them marks. Let's give them some marks, okay, performance marks, and then remember performance marks as given, and then also 8 people also were also given the new training, and then their marks are also recorded. All right, so is there evidence, means per the data you have, is there evidence that the new method has led on average to a higher scores at 5% level of significance? So this thing, what you are saying is that, okay, we had an old method and then we brought in a new method. Now as a company or as an institution, we want to find out whether the new one we brought indeed better than the old one. Because if you don't do that, then you won't be able to know how effective this one is. So you have to be able to say that yes, the new one I brought is indeed better than the old one that is existing, isn't it? Before you can carry on using the new one, isn't that? So in a way, sometimes you might even be seeing that the new method, the marks they are getting is higher, but statistically those apps will not be significant to determine a difference in their performance, or how better one is to the other. Okay. So that is why you have to go ahead and perform a statistic or a statistical test to be able to evaluate how well the new method has been, okay, in the system. Right. So to do that, we are assuming that they are independent. So we are saying that the 6 trainees are coming from some populations, and then the 8 trainees are also coming from some population, and then their marks are given. So we are also assuming that the data points are continuous. Okay, so we believe that the marks can take anything. So somebody can get 243.66 marks, maybe it's an exam mark. So we believe that he can take any of these. That so all these assumptions for t-test, we are believing that this data point has them. Okay, so we'll go ahead and do the test. Remember that our test we are doing is that we are doing a t-test for independent, and then we are assuming on equal variance. Okay, so we are assuming that the first population here has different variance from the second population here. Okay, that means the variation, when we say variance, you know, the central tendency, which is the mean of this, we are looking at how these values are varying. They are different from the central mean or the mean. Okay, so that is actually what we are trying to look at. Okay, all right, so we'll look at this in the next video. So make sure you subscribe to the channel, hit the like button, and then turn on the notification so that when a new video is uploaded, which is a continuation of this one, you have access to that, and then we'll just be fine.